Yeah, please confirm me whether I'm audible or not. Please confirm me my audibility. Yes, everyone. Yeah. Yeah. Hello, everyone. So this lecture is a free lecture for this TS GENCO examination preparation. That is control systems. Our subject we are going to start with control systems. Control system is one of the important subject for TS GENCO examination. There are many subjects. In those subjects, control systems is one among. Okay, but it is having good weightage. In the previous papers also, you can find some 8 to 10 marks used to come. But these days, three new subjects were added like heat transfer, thermodynamics, and material science. Maybe the weightage of each subject may decrease, but it is not too much. Maybe 1 or 2 marks it may decrease. At least 5 to 6 marks. At least 5 to 6 marks you get from this subject. So let's enter into the subject. Our subject is control systems. Our subject is control systems. See, I'm going to discuss the first syllabus. I'm going to discuss first the syllabus. Then I'm going to discuss the very first topic in the first chapter. Very first topic in the first chapter. Okay, that is basics of control systems. In basics of control systems, Laplace transform is very important. Total entire control systems we are going to discuss in S domain. In S domain, see here one point is very clear. Do not go for the research in a subject when you are preparing for competitive. That is what the mistake done by most of the students. Most of the students will commit this mistake. That is, they will go for in-depth concepts, not required. For TS GENCO examination, not required. If you are going for Baba Atomic Research Center, BARC, or I can say DRDO or ISRO, then I surely say that, yeah, please study in this way only. But this is TS GENCO examination, state level examination. And if you see the previous papers, the questions are very easy to moderate only. Never tough questions were asked. So my subject is control systems. My subject is control systems. Easy subject. So why I'm starting with control systems means easier scoring subject. Everyone can get full marks in this control systems. Okay. So yeah, subject is easy, but I can say it is easy if and only if you prepare this way. Okay. First, let's start the syllabus, please. Syllabus. The syllabus is first chapter is yes, basics of control system. Basics of control system. The second chapter is signal flow graphs. Signal flow graphs and block diagrams. Signal flow graphs and block diagrams. Third chapter is time response analysis. Time response analysis. See, in this chapter, definitely you get one question. Which kind of question you get? They will give you one problem. If you see that problem, you feel that the calculator is definitely required. But if you follow the logic, calculator is not required. See, I can say questions in TS GENCO examination are little logical. Okay, I won't say too much logical, little logical. That is, if you look at the question, you feel like you need definitely calculator. You need definitely calculator. But without calculator, we can solve those problems. But you need not have good calculation skills. I didn't mean to say that. People will misunderstand. Without calculator means, sir, I must be very good at calculations orally or normally without calculator. Not required. If you put some logic, some simple sense, then definitely you're going to get the answer. It is four options will be there. For that given question, all the remaining three options can be eliminated from the concepts. That way we are going to follow. The third chapter is one of the important chapter. The next fourth chapter is stability. In stability, see the chapter stability, all shortcuts we are going to learn. All shortcuts we are going to learn. Okay, stability. See, stability total chapter shortcuts only. No general method, not required. Why? Because general method you teach, but that much I can say width not required. Why? Because any question given from this stability chapter, 30 seconds is only the time we are going to take. Directly we will take the answer. Okay, yeah. The next one is root locus. Yes, root locus diagram. Yes. Next one is controllers. In controllers, no big topics. We are not going to take big topics, design of controller and all, but which controller is used to reduce steady state error, which controller is used to improve time response characteristics. So like that, a very simple way we are going to learn controllers. Okay, next one is introduction to frequency response. Introduction to frequency response analysis. In this one, we are going to learn gain margin, phase margin formula, how to use it, how to apply it. Again, shortcuts comes into picture at this seventh chapter called Introduction to Frequency Response. Introduction to Frequency Response. Okay, yeah. Next chapter is Bode plot. See, no one asks you to draw Bode plot in the examination, but that fellow himself will give a small Bode plot. He will ask you to get the transfer function of the Bode plot. We call it as simply inverse Bode plot, but we are not going to sketch any plot. That fellow will give one plot. He may ask you what is the slope, initial slope, final slope. Somewhere he mark in the diagram and he will ask what is the slope there and all that way, right? Next, ninth one is polar plot. Polar plot. 10th one is Nyquist plot. See, Nyquist plot, actually Nyquist stability criteria is a big one to understand. But in very simply, with respect to examination point of view, we are going to learn this Nyquist plot, right? Then after that, we have, I can say, state variable analysis. State variable, yes, analysis. So after that, last topic is compensators. What is that? Compensators. So this way, or this one can be up, this one can be down, no problem. So this is a total syllabus. In basics itself, we are going to see mathematical modeling also. Don't think like, sir, we are not. Are you not covering mathematical modeling? That is also we'll see in the basics only. In the basics like mass, spring, dashboard, these things are going to take up, and we are going to develop force voltage analogy, force current analogy. See, we are not going in depth. Okay, not required. Just to the level of examination we are going to take up, because hardly you are left with 50 days for your T GENCO examination. On December 3rd exam is, so we have to go that much in depth. So my first topic is basics of control systems. Yeah, the very first topic is basics of control system. Yeah, basics of control system. See, once you are done with the first chapter, remaining all chapters, once you listen, you will remember, you will understand, you are going to understand, you are going to remember it forever. That much important this chapter is. See, in basics of control system, the first thing very much required is Laplace transforms of various signals. Why? Because, see, in time domain, we have lots of problems, like convolution is very difficult in time domain. You can't apply KVL, I can say, you can't apply voltage division, current division, these two techniques in time domain, and Ohm's law also, if there are energy storage elements. That's why you're going for frequency domain. So see, there are some disadvantages of time domain, that's why we're going for frequency domain. So what is a tool that is used to convert from time domain to frequency domain? Laplace transform. Again, we have to convert from S domain to time domain. What is the tool we are going to use? Inverse Laplace transform. So one must be very clear. One must be very clear with this Laplace and inverse Laplace transforms. Okay, yeah. So simply, if see, this question was previously asked. So this way, the question was previously asked. See, there is a signal f of t. There is a signal f of t. If you apply Laplace transform to that, you are going to get f of s. You're going to get f of s, right? So what is how to see? This is the symbolical I'm showing. Symbolical I'm showing. So this is not the example. Example I take it up later. Example previously asked a question I take it up later. See, now if you apply, suppose if you have f of s, if you want f of t, you have to apply inverse Laplace transform. Then you are going to get f of t. So f of t to f of s. So simply instead of this way, I can call, if you have f of t, then if you apply Laplace transform, you are going to get f of s. See the arrow. So f of t to f of s, that is, this is from f of s to f of t. Now you may ask, sir, what is the formula for Laplace transform? Everyone will take this way, 0 to infinity, integral 0 to infinity, not correct. Integral minus infinity to plus infinity. So f of s is equal to integral minus infinity to plus infinity f of t into e power minus st dt. That particular integration you have to perform. That particular integration you have to perform to get the Laplace transform of the signal f of t. If you want the Laplace transform of the signal f of t, that particular integration you have to perform. See, you see, this e power minus st is called as kernel. S is the Laplace operator, S is the Laplace operator, and we are doing integration with respect to time. Then you're going to get the signal in S domain. So come on, where f of t is the signal. Integration limits are from minus infinity to plus infinity. We have two types of Laplace transforms. One is bilateral Laplace transform, and one is unilateral Laplace transform. See, what is this? This is bilateral. Bilateral means both sided. See, I'm taking the integration limits from minus infinity to plus infinity. So entire time region I'm taking, that's why it is called as bilateral Laplace transform. If you want unilateral Laplace transform, integral 0 to infinity f of t into e power minus st dt. So this is called as unilateral Laplace transform. This is called as unilateral Laplace transform. See, now here a question that comes into student mind, that is, sir, which Laplace transform I have to find in the exam, bilateral or unilateral? Yeah. Suppose this question is given. This question is given previously in the examination. See, question is, if f of t is equal to 1, then Laplace transform of f of t, Laplace transform of f of t is dash. Now the question is, he simply mentioned it as Laplace transform. Neither he mentioned bilateral nor he mentioned unilateral. Now which one I have to find, sir? By default, bilateral Laplace transform. If nothing has been mentioned by him, if nothing is mentioned by default, you have to take bilateral Laplace transform. The solution is f of s is equal to integral minus infinity to plus infinity. F of t is 1 into e power minus st dt. If you do this, e power minus st by minus s integral from minus infinity to plus infinity, you're going to get it as infinity. Yeah, if you substitute these limits in this particular, I can say function, you're going to get in the place of t, you're going to get it as some infinite, so not defined, okay? So you're going to get it as infinity, simply you're going to get it as infinity. So Laplace transform means I have to get a function in S domain, but I'm not getting it, it is not defined. So Laplace transform of 1 does not exist. So answer is, see, the options will be like this. I forgot to give the options. So the option A is 1 by s. Option B is s. Option C is minus 1 by s. Option D is does not exist. Does not exist. Yes, it does not exist. Many people, they learn, they won't even perform. They just remember that Laplace transform of 1 is equal to 1 by s. They will take this one as the answer, but it is wrong. Now, why? When 1 by s is correct? When 1 by s is correct? Now, if this is the question, the unilateral Laplace transform of f of t is equal to 1 is dash. Now, this answer you are going to get it as 1 by s. The solution is f of s is equal to integral 0 to infinity, f of t is 1, e power minus st dt, e power minus st by minus s, integration from 0 to infinity, you are going to get it as 1 by s. So here, my main stress point here is, if not mentioned anything, by default we have to find the bilateral Laplace transform, means we have to take the limits from minus infinity to plus infinity, not from 0 to infinity. If he says clearly that unilateral Laplace transform you want, then we have to take from, I can say, we have to take from 0 to infinity. So what is the Laplace transform of 1? Laplace transform of 1 does not exist. Laplace transform of 1 does not exist. Please comment now. Please comment on the answers. Please comment on the answers. Okay. Yeah. If you have any query, also you can post in this live chat. Yeah. Live chat is going. Yeah. I'll reply. Just I'll see your question, then I'm going to reply you. Right. Yeah. So this is about The very first thing that is Laplace transform. That is Laplace transform. See, somebody is saying that resound is coming. Is it? Now you're getting, now you're experiencing resound. Gautam, yeah. Please comment again that whether you're getting resound or that problem is solved. Okay, I'll be waiting for your comment. Yeah, that is about the Laplace transform of one. See, we have many signals. We have many signals like impulse signal, step signal, ramp signal, parabolic signal, and I can say exponential. All those Laplace transforms and inverse Laplace transforms we are going to complete. Okay, observe here. Next is Laplace transform of del of t. Del of t is impulse. In fact, unit impulse. Or I can say a del of t, where a is the area of the impulse. Where a is the area of the impulse. Let's find this one. Integral of minus infinity to plus infinity f of t a into del of t into e power minus st dt. But we know that one thing we know that this del of t impulse signal is going to exist only at t is equal to 0. Therefore, integration limits I have to take from 0 minus to 0 plus a into e power minus st dt. Integral 0 minus to 0 plus this e power minus st is going to be 1. Now, answer is A. Laplace transform of del of t, a del of t. In fact, a del of t is equal to a. One thing is very important for us here is, let me write it in the form of note here. Let me write in the form of note here, that is Laplace transform of a del of t is equal to a. Then what is inverse Laplace transform of a? Inverse Laplace transform of a is equal to a into del of t. Means if you take any constant in S domain, its inverse Laplace transform is a into del of t. See, Laplace transform means time domain to frequency domain. Inverse Laplace transform means frequency domain to time domain. Frequency domain to time domain, right? Frequency domain to time domain. Please comment. Is there any resound problem? Please comment me if there is any resound problem, right? Yeah. Let's see the next thing that is. Let's see the next thing that is step signal. Yeah. Laplace transform of a into u of t can take. A is the magnitude of the step. A into u of t. That is integral. U of t is a signal which is existing only from 0 to infinity. It is not existing from minus infinity to plus infinity. Though you take the limits from minus infinity to plus infinity, f of t is what a into u of t into e power minus st dt. Now throw that a outside. This u of t is unit step signal which is existing from 0 to infinity. You know, step signal looks like this. Those who don't know about step signal can see, yes, this is 0. Here only it rises. Before that it is 0. Before that it is 0. Therefore, integral 0 to infinity e power minus st dt, that is equal to a into e power minus st by minus s from 0 to infinity. If you solve it, you are going to get it as a by s. Laplace transform of a into u of t. If you solve it, you are going to get as a by s. Just substitution. Just it is simply substitution. Now, let me ask you one question. Let me ask you one question. Yes, fourth question, that is what is inverse Laplace transform of 6 by s plus 7? I want the inverse Laplace transform of 6 by s plus 7. I will give you, yeah, I will give you, yeah. Somebody asking, sir, whether it is EC course. Yes, it is. This is this subject is for both EC and Triple E. For both, I can say it is Mirza Beg. Someone commented EC course. Yes, it is. Control systems is a subject which is applicable for both EC and electrical. Okay, for both of you. Okay. Now this question I given, I am waiting for your answer. Can you please solve? See, getting Laplace transform is easy, but inverse Laplace transform we are not going to apply any formula directly. Directly we are going to get the answer by using inverse Laplace transform. See, we can split like this: inverse Laplace transform of 6 by s plus inverse Laplace transform of 7. Now, inverse Laplace transform of 6 by s is nothing but 6 into u of t. Just previously we learned Laplace transform. Yeah. What is Laplace transform of a into u of t? A by s. Now from this one, I can write a note point, that is, inverse Laplace transform of a by s is equal to a into u of t. Vice versa it is. If you are applying Laplace transform to this a into u of t, you are getting a by s. then if you apply inverse Laplace transform to AVS, then definitely you have to get A into U of t. A into U of t, right? A into U of t. Somebody commented something. Let me see. Let me see what is their query. Yeah. So when the classes for mechanical engineering, soon we will let you know. Soon we will let you know about the classes of mechanical engineering. Yeah. So it is A into U of t. Let's go forward. Let's go forward. Yeah. Observe it. 6 into U of t. Now 7 is nothing but 7 into del of t. Yeah. Yeah. Previously we learned one thing that del of t Laplace transform is 1. A into del of t Laplace transform is A. Right? Here it is a 7, means a 7 into del of t. We know, see, this again I am writing. We know the formulas that Laplace transform of A del of t is equal to A. Inverse Laplace transform of A is equal to A into del of t. Laplace transform of A into U of t is equal to A by S. So inverse Laplace transform of A by S is equal to A into U of t. So vice versa it is always. Vice versa it is always. Okay. So please do understand this way, then every problem is going to be easy for us. Now here one mathematical formula I want to give you, that is note point, that is simply Laplace transform of A into t power n into U of t. The formula is some magnitude A, throw it outside, t power n factorial by s power n plus 1. Yeah. If you have t power n, A is the magnitude, throw it outside. Okay, that's that. This A is not going to affect your Laplace transform, but it has to be there, but it is not going to have any separate, I can say, priority. It is a multiplication factor. Okay. T power n means n factorial by s power n plus 1. S power n plus 1, right? Now, from that, let me give you one question. What is the Laplace transform of 3t into U of t? Laplace transform of 3t into U of t. Very simple question I given. Laplace transform of 3t into U of t. Anyone? Yeah, please comment your answer. Yeah, the people who are watching this class, please try to answer it. Yeah, 3 is 3 only. T means t power 1. So 1 factorial by s power 1 plus 1. That is equal to 3 by s square. That's all. 3 by s square. Right? Let's go to the next question, that is of inverse Laplace transform. See, in our classes, the learning and applying, everything will take place in the class only. Okay, you need not to learn separately. Okay, we learn here, we apply here. We are going to solve number of problems. See, the best way to prepare for competitive examination is by solving more number of problems. If you know the concept, solving a problem is going to be very easy. That's why first concept, then problems. Okay, yeah. Let's go to the next question. That is, what is the inverse Laplace transform of 3 by s cube? 3 by s cube. Yes, I'm waiting for your answer. Anyone? 3 by s cube. See, 3 is 3. You keep it. Now 1 by s cube we have. 1 by s cube we have. Right? It's inverse Laplace we want. Now what is the previous formula? What is the Laplace transform of t power n into U of t? That is n factorial by s power n plus 1. Now that is 1 by s cube, means n plus 1 is equal to 3. So n is equal to 2. Therefore, yeah, 3 into t square. But here 1 is there. Definitely you are going to get 3 here, right? If there is a 2, if there is 2, I can say, see, don't get confused here. Here students will get confused. N factorial. Here what I do is I multiply with the 2, divide with the 2, then it will be 1 by 2 into 2 by s cube. This 2 by s cube is nothing but I can write it as 1 by 2 into 2 by s power 2 plus 1. Now n is 2. Now it is valid, right? So 3 into t square by 2 into U of t. Yes, 3 by 2 into t square into U of t. That is the Laplace transform. Inverse Laplace transform, sorry. Inverse Laplace transform. See, Everyone will do Laplace transform, but most of the students will fail in inverse Laplace transform. As I'm telling, one question is guaranteed from this area, right? The next is, I can say, uh, question number 6. Laplace transform of e power minus 2t into u of t. Simply apply this formula. See, once we apply the formula, after that we are going to remember it, then we are going to extend it very easily. So integral, as u of t is there, signal is exists from 0 to infinity only, e power minus 2t into u of t is 1 into e power minus st into dt. So that is equal to integral 0 to infinity e power minus t you take common, then it will be s plus 2 dt. So from if you do this one, you're going to get 1 by s plus 2. Yeah, just integration only. I skipped that integration step. Integration of e power minus x will be e power minus 2 at, whatever it is, at will be 1 by a, 1 by a, and integration limits short substitute, we call it as 1 by s plus 2. You can check. You can check. Yes, you can check it as you are going to get it as 1 by s plus 2. There are some comments. Let me see. Any, I can say like questions and answers. Let me see. Yeah. Yeah. Aditi Gupta. Hello, ma'am. Yeah. Yeah. Thank you. So 1 by s plus 2. 0 to infinity e power minus t into s plus 2 dt 1 by s plus 2. See, the point here is how to remember that. Simply, note point here. The note here it is integration of, not integration, sorry, Laplace transform of any signal e power at into u of t. In this format, it is there. It is 1 by s minus a. 1 by s minus a. Okay, see, sir, how you got, if you ask me, sir, how you got this one? Very simple, this way. Here minus 2 is there, here minus 2 is there. The same I got here in the denominator as plus 2. Okay, here I'll tell you to remember some identities, that is, suppose, not try to remember, just try to understand and apply, very simply. In some example I'm taking, see, Laplace transform of e power minus 3t into e of t, we are going to get it as 1 by s plus 3. Now, Laplace transform of e power plus 2t into u of t, you are going to get it as 1 by s minus 2. 1 by s minus 2. See, one observation you have to make here, that is, here plus minus 3 is there, you are going to get plus 3. Yes, here minus 3 is there, you are going to get here plus 3. Here 2 is there, you are going to get minus 2, right? You are going to get here minus 2. So from this one, understanding inverse Laplace uh, is important. Understanding inverse Laplace transform is important. Okay, observe here. What is inverse Laplace transform? That is note. Try to understand this way. Please try to understand this way. Inverse Laplace transform of, suppose I write it as 1 by s plus 9. The very first thing you have to understand is s is having plus something. S is having plus something, right? How much it is having s plus 9. So definitely, first of all, u of t will be there. U of t will be there. S plus something in the denominator, not s square, not s cube, s plus something. So it will be e power minus 9 into t. You can see the previous things. Here, minus 3 and u of t is there to the exponential. That's why I got 1 by s plus 3. Here plus 2 minus 2, right? So this way we have to understand. Right? Next, what is inverse Laplace transform of 1 by s plus 2 whole square? Anyone in this class who are watching this class, please. Anyone who is watching this class, please try to answer it. I'll wait for your answer for 1 or 2 minutes. Let me see. Let me see. How many of you going to answer? Let me see. Yes, please. Anyone? Yeah, I'm waiting. See, one thing is very clear. S plus 2 square. First of all, this s is having plus 2, not s square is having plus 2. People will misunderstand, sir. S square is having plus 2. No, s plus 2 whole square it is. Forget about that square, first of all. S plus 2. Because of that plus 2, you are going to get e power minus 2t. Once that e power minus dt you wrote, then it will be simply 1 by s square only. Why? Because of that plus 2 only you wrote as e power minus 2t. Because of that plus 2 only you wrote as e power minus 2t. Now this is into t. 1 by s square means what? 1 by s square. Previously, yes, previously we did. Yeah, if you go back, previously we did it as yes t into u of t. T into u of t is going to give by s square. By s square. The same here. Yeah, the same here. That is the same here. That is 1 by s square means t whole into u of t. See, what I want to convey here to you is inverse Laplace is important. Okay, Laplace is very easy. Laplace is very easy, but inverse Laplace is very important. If you understand Laplace properly, then inverse Laplace is going to be easy, right? Then next Laplace transform is of sine and cos. I will tell you the formula, remember it and apply it. I'll tell you the formula. Yeah. Example, that is, or not example, let me take sine and cos. Let me take sine and cos. So Laplace transform of a sine, yes, omega t into u of t. Why, sir, you are taking a again and again and again? A is some magnitude. A is some magnitude. It may be any value. It may be equal to 1 or less than 1 or more than 1. We are not going to bother about it. Okay? That a, we keep it outside. And what is the Laplace transform of sine omega t? What is the Laplace transform of sine omega t? That is omega by s square plus omega square. See, remembering that one is very. You can derive. We can derive by taking integral 0 to infinity e power minus st to f of t dt. That is a lengthy process for our examination. Just understanding in a logical way, remembering in a logical way is very important. Observe it, please. Observe it. Please, any comments you can comment if you want any clarification on the previous things, or if you have any answer for previous things, also you can comment. So a into omega by s square plus omega square. So if you find the denominator as s square term and s power 1 term is missing and constant, then perfectly it is sine with constant in the numerator. With constant in the numerator. Now cos also I write here itself. Therefore that is easy for you. A cos omega t into u of t. A cos omega t into u of t. A you keep as it is a multiplication factor, I'm keeping it outside. As it is cos means s by s square plus omega square. You have to learn the difference between sine and cos. You have to learn the difference between sine and cos. That is, in the numerator, if constant is there, it is sine. With the denominator s square term and constant. S square term plus constant. Right? S square term plus constant. Okay? So, in the numerator, if you have s term with the s square term in the denominator plus some constant, it is cos. Please do remember. Okay. Let me take Laplace first example. I'm taking yes. Laplace transform of 2 sine 3t into u of t. So 2 is constant, keep it outside. In the place of omega, I have 3. Omega by 3 by s square plus 3 square, that is equal to 6 by s square plus 9. 6 by s square plus 9. Clear? 6 by s square plus 9. Now, let me go for one more question. Laplace transform of, I can write 10 cos 3t or 10 cos 5t. Let me take it as 10 cos 5t into u of t. That is equal to 10 is 10, you keep it outside. Cos 5t, s by cos is going to have s term in the numerator, I told you already. S by s square plus omega square is 5 square, then you are going to get it as 10s by s square plus 25, s square plus 25, right? So getting Laplace is easy. Then let's see the question on inverse Laplace transform. Yeah, an example, that is inverse Laplace transform of I can write it as 10 by s square plus 3. Many people will get confused here. That is, sir, how to do it? Blind, I'll say, Look at the numerator and denominator. Numerator is constant, first thing. Second thing is denominator is having s square term plus constant. Then pakka it is sine. It is sine. Sine means it should be like omega by s square plus omega square, na? Right? Now what I do is inverse Laplace transform of 10 by s square plus that 3, I'll write it as root 3 square because I have to rearrange the given question in the form of s square plus omega square, right? So that is equal to inverse Laplace transform of 10 I keep here, I multiply with root 3, I divide with root 3, and this is s square plus root 3 whole square, right? So that is equal to inverse Laplace transform of, I do one thing, 10 by root 3 I keep outside. 10 by root 3 I am keeping outside. Then it will be inverse Laplace transform of root 3 by s square plus root 3 square. Now 10 by root 3 into, this is omega by s square plus omega square, nothing but sine root 3t into u of t. Sine root 3t into u of t. You see? So the very important point to understand here is convert any given function into standard form. Say all we learn first standard forms. If any question is not given is not in the standard form, convert that one into standard form. Right? Now let's do this question, please. Let's do this question. So inverse Laplace transform of, simply inverse Laplace transform of I can say s by s square plus 7. The point anyone to understand here is s by s square plus 7. So numerator is having s term, denominator is having s square plus some constant. Therefore, it is definitely cos. It is cos function that can be written as inverse Laplace transform of s by s square plus root 7 whole square, that is equal to s by s square plus omega square. It will be cos omega t into u of t. Cos omega t into u of t. So this way we can understand very easily. We can solve any problem very easily. Solve this question. I am giving you time to solve this question. Inverse Laplace transform of s plus 2 by s plus 2 whole square plus I can say 9. Answer for this one, please. I'll wait for your answer. I'll wait for your answer. Anyone can answer. Anyone can answer, please. Yeah. I'm waiting for your answer, ma. I'm waiting for your answer. Yes. Yeah, please. Please. Answer, please. Simply, see, I'll tell you. I told you that whenever to the s term something is added, due to that we get exponential in time domain. If it is plus 2, therefore I have to take it as minus 2. Now, forget about this. Forget about this plus 2. Forget about this plus 2. Now it is simply s by s square plus some constant that can be written as inverse Laplace transform of s by s square plus that 9 can be written as 3 square. 9 can be written as 3 square. S by s square plus omega square is nothing but cos 3t into u of t. Cos 3t into u of t. Right? So this way, Laplace transforms and inverse Laplace transforms, we are going to play very simply. I did not taken for any question more than one step, you see. More than one step I did not taken. Maybe for your explanation purpose, I might have been taken more than one step, but almost all, either it is Laplace or inverse Laplace, we taken all only single step. Once we learn this way, any concept in the examination, we are going to solve it very easily, and we are going to save our valuable time. So hoping all of you to attend these free classes, utilize these free classes, and join your hands with your peer to accelerate your preparation. We'll meet in the next class. We'll meet in the next class. Thank you.